Welcome to the channel of Digital to Real. Today I am going to discuss about the Verilog Generate Block. Why the Verilog Generate Block is used in the Verilog code. What are the various types of statement available for Generate Block. We will see the examples for each of the type of the Generate Block statements to make the things clear. So I start with Verilog code is made reusable by Generate statement. Reusable means what? Suppose I have written a Verilog code. In some point of time, I want to have the same Verilog code but with some additional feature when a certain condition is met. And when that certain condition is not met, I do not want to use the particular feature. In that case, generate statement can come for use. Similarly, there is another provision of generate statement to generate blocks iteratively. Suppose one instant of RAM I have specified. I can make use of the same RAM instance and I can make multiple RAMs and make the connection also. For that purpose, I have the generate for statements. So the generate statement includes generate for block, generate if block, generate case block. The reusability of the code allows us to reduce the development time for future projects. As I said, when a new feature of the code I need to add into the existing code, I can simply make use of the generate statement under certain condition. I will generate it. If that condition is not met, I will not generate that piece of code. This is all possible in synthesizable code. So, this reusability feature the generate statement makes available. Now, Verilog generate statement is used to write synthesizable code. Means the code can be synthesized. We generate conditionally or iteratively generate blocks. The two types of generate blocks are there specifically. One, we generate a piece of code on a particular condition being met, and another generate iteratively. Just like a for loop, what it does, it runs the loop depending upon the number of times mentioned in the initial, means the starting stage and the stop stage of the variable mentioned in the for loop. That many times it is run. Similarly, generate block can generate a one piece of code iteratively as number of time as it is mentioned in the for loop start and stop points. Generate statement is used in concurrent Verilog code blocks. Concurrent means those which are run parallelly. Okay, they are called concurrent blocks. So generate statement is used in concurrent Verilog code blocks. It cannot be included within always block or initial blocks, because we mentioned begin and inside the always block and initial blocks also, where the piece of code is run sequentially. So generate statement is not used there. We have to use either an if statement, case statement or a for loop in conjunction with the generate keyword. So generate is a keyword, and with generate keyword we can have generate if statement, generate case statement and generate for loop statement. Now we use if and case statement to conditionally generate code, while for generate statement iteratively generate codes. The generate block was introduced in Verilog 2001 standard. Okay, and in Verilog 1995 standard this generate block is not included. Now we will see the generate block for loop in Verilog. So generate for loop in Verilog. So here is the code snippet. We will see how the syntax of Verilog code having the generate for loop looks like. So we will have a variable gen var, and gen var name is the name of the variable, semicolon. Code for generate block is we will have the generate keyword then for. Then inside the for, we have, inside the brackets for the for, we have the initial condition, semicolon, stop condition, semicolon, increment. These three are mentioned. After, we have the begin and statement. Inside the begin and statement, we will put the code which we want to execute. We want to implement that piece of code, we will put here. Code to execute. And after begin and, we have the end generate for the generate keyword. So this syntax of generate statement for this particular generate for looks quite similar to the Verilog for loop. But there is a difference between the generate for loop and Verilog for loop, and we will see that. Now here is the example which is using the for loop. This is simple for loop, Verilog for loop. Always at the rate of passage of the clock, begin for I is equal to 0, semicolon, I less than 2, semicolon, I is equal to I plus 1. Now we will have begin and statement. Inside the begin and statement, sig underscore a, index is I, is equal to 1 tick B0 semicolon. And here is the end for the begin statement. So this is a always block, okay? And for loop is used inside the always block. Sig underscore a is a vector, and I will assign the value 1 tick B0 from I0 to I1, means 2 values only. Now example using generate for block. Okay, earlier one was Verilog for, here it is generate for. Generate for I is equal to 0, semicolon, I less than 2, semicolon, I is equal to I plus 1. Begin. Inside the begin, for this begin there is this end. Begin and I am having this always block. Always at the rate of passage of the clock, again begin and sig underscore a, this particular signal, index is I, is equal to 1 tick B0 semicolon, and here is the end for this begin. Now we will unroll the for loop example. First example, Verilog for loop. Okay, I will unroll it. This was the Verilog code. At the passage of the clock, we were having a for loop. So I can put it like this. Instead of for loop, what I can have it? I can have sig underscore A0 is equal to 1 tick B0. Sig underscore A1 is equal to 1 tick B0 semicolon. So here that is what has been put. Unroll the for loop example. This is what has been put. Here is the generate for loop. You see again. Generate for I is equal to 0, I less than 2, I is equal to I plus 1. Inside that I have the always block as passage of the clock, and sig underscore a of I is equal to 1 tick B0 semicolon. Now I am unrolling this one. So now it is look like something like this. Always at the rate of passage of the clock, begin and, inside begin and I have sig underscore a, 0 is equal to 1 tick B0 semicolon. Again same replication of the code I have. Always at the rate of passage of the clock, begin sig a. Here directly I have put 1 is equal to 1 tick B0 semicolon n. So this is how is the difference between the for loop and the generate for loop. Hope it is little bit clear to you on unrolling the code. Now we will see the Verilog generate for example. A detailed example we will see for generate for loop. Okay, let us consider an example where we use an array of 3 RAM. We will have 3 RAMs here. Okay, and it is an array RAM 0, RAM 1, RAM 2. Modules which are connected to the same bus, and the 3 RAMs are connected to the same bus. You see the diagram here. RAM 0, 1, 2 is there. Here is the clock line is there. Here is the bus line is there. This bus line is connected to write enable, address and write data. All 3 of them are tied. We will have a common bus for write enable, address, write data tied to RAM 0, RAM 1, RAM 2. Here is the clock connected to all the RAMs. Enable 0 is here connected to enable pin of the RAM. Enable 1 is there connected to the enable input of the RAM 1. Enable 2 is connected to the enable input of the RAM 2. You see the diagram here. So these are individual inputs. Apart from that, the individual output is read underscore data 0, read underscore data 1 and read underscore data 2. So each RAM module has a write enable port, that is write underscore en, a 4-bit address input and a 4-bit data input. Okay, and all the signals are connected to the same bus. Each RAM module has a 4-bit data output bus. I spoke about RD underscore read data 0, read data 1, read data 2. And there is an enable input also independently applied to all the RAM block. Now we declare a 3-bit vector where each bit connected to the individual RAM enable ports are connected respectively. Means 3-bit vector we will make it for the enable 2 down to 0. 0 bit connected to RAM 0. 1 bit is connected to RAM 1. 2 bit is connected to RAM 2. So this is how the connection of 3-bit vector. Then for data output bus, we create a 12-bit vector. Here 12-bit vector is there. 0 to 3. 0 to 3. This slice is for the output of the RAM 0. Then another 4-bit, next 4-bit. 7 to 4 is connected to RAM 1. And 11 to 8 is connected to RAM 2. So we will have 4-bit slices of the vector connected to 3 RAM. Now for data output, we can also create an array which consists of 3 4-bit vectors. So the read data, it is of 4 bits for each of the RAM. So we will have an array of 3. So the index of the RAM would be, index of the read data would be 0, 1, 2. And each one would be a 4-bit. Now we will use the generate loop. We can use the loop variable to assign the different elements of this array as required. Here is the code snippet I have written for generate for statement regarding this particular RAM design. So first of all, I am declaring a wire 3 down to 0 read data, and it is an array of 3 0 to 2 semicolon. Now I will write the vector for enable. So comment vector for the enable signals, wire 2 down to 0 enable semicolon. Now gen var is a variable to use in the for loop. For generate keyword and generate for loop, we will have a variable gen var. A variable will be declare it as the gen var and we will use it in the generate for loop block. Gen var I semicolon generate for I is equal to 0 semicolon I less than equal to 2 and semicolon I is equal to I plus 1 bracket close begin. Now this is the RAM, module name RAM, module instant RAM underscore I. Inside the bracket I have dot clock connected to clock, dot enable connected to enable I, dot write enable is connected to write enable, dot address connected to address, dot write data connected to write data, dot read data connected to read underscore data I. So 3 usage of I. Here I is used, gen var I, that I is used here, that I is used here and the I is used here. These are particularly to connect to the RAM instance, RAM underscore 0 1 2 it would be generated, and for the respective RAM the connection of the enable pin and the read data is done, and this clock enable, write enable and write data are common to the bus. So here is the end and here is the end generate for the generate keyword. The final synthesizable code having the generate for loop will look like this. Gen block 1 0 dot RAM underscore I. This is the instant 0, instant 1, instant 2 of the RAM underscore I. Okay. And here these are the 3 RAM. The connection has been made. Read underscore data 0 out. 3 down to 0 is connected to read underscore data, the index was there 0. It was a 2-dimensional array, 3 down to 0 for RAM 0. This was the index for RAM number, and this is the number of bus line, that is 4. Here it is connected to read underscore data 1, 3 down to 0. This is connected to read underscore data 2, 3 down to 0. Here the connections are clock connection is common to all the RAM. There is enable pin 2 down to 0. 0th is connected to this RAM, first bit connected to this RAM, second bit is connected to this RAM. Other lines, address 3 down to 0, write data 3 down to 0, and write enable, they are common to all the RAMs. Hope you are able to understand the generate for block. If you like the video, share with your friends. Please subscribe the channel and have a very nice day. This video would be followed by the generate block of if and case statement. Generate if and generate case.